What if the next generation of artificial intelligence isn't built by one massive tech giant operating behind closed doors, but by thousands of computers working together on decentralized blockchain networks? Today, we are exploring the wild intersection of AI and crypto. We're unpacking the top projects in the space and seeing how they actually work under the hood.
Welcome back to The Explainer. So, if you're a focused learner trying to understand exactly how artificial intelligence is merging with decentralized blockchain tech, you are absolutely in the right place. We're skipping past all the speculative hype today to look at the actual, tangible infrastructure being built right now. We're going to explore how these networks are trying to build a decentralized alternative to the centralized AI models we use every single day, and we'll dig into the real-world applications driving this massive shift.
All right, here is our roadmap for today. We're going to conceptually build a decentralized AI computer, layer by layer. 1. The compute layer. 2. Execution and agents. 3. Storage and data. And 4. A much-needed reality check.
Let's start right at the base, Layer 1, the compute layer, or mining for machine intelligence.
Okay, so if you're familiar with traditional crypto, you know Bitcoin uses mining to secure its network by solving random math problems, right? Well, a project called Bittensor takes that exact concept and makes it programmable for AI. Instead of crunching random numbers, miners are literally mining for machine intelligence. The network is broken down into 128 distinct subnets. Think of these like specific, highly competitive task contests. You might have one for AI-powered coding, another for discovering new pharmaceutical molecules, and another for generating 3D objects. Every single day, the network mints 3,600 TAO tokens, and miners all over the globe are competing within these subnets to provide the absolute best AI outputs to win their share.
And make no mistake, this is a ruthless system. Researchers looking at the network actually describe it as, quote, contests within contests. It's very Darwinian. It's very Hunger Games. The network is constantly evaluating performance, and the weakest links are literally culled by the chain. If your performance drops, your right to mine is rescinded. But for the winners, they can earn massive rewards for providing top-tier AI services.
Which brings us to a really clever piece of tokenomics. Holding the native TAO token is essentially like holding an S&P 500 ETF, but entirely for AI startups. Because TAO is the universal entry currency for every single subnet in the network, its value tracks the combined success and utility of all 128 of those individual task contests. So if even one subnet breaks out and sees massive demand, the overarching TAO token benefits from that success.
Moving up the stack, we have Layer 2, execution and agents, focusing on autonomous execution. So we've got the raw intelligence from the compute layer, but now we actually need software agents to use it. Enter the Artificial Superintelligence Alliance, or ASI. This is a massive consolidation in the space, merging several existing projects into one unified full-stack infrastructure. You've got Fetch.ai handling the autonomous agents. These are software programs that can independently book travel or optimize supply chains. You've got SingularityNet providing a marketplace for the AI models. Ocean Protocol handles privacy-preserving data exchange, and Kudos provides the decentralized compute. Unified under that one ASI token, these agents can now discover, negotiate, and transact with each other entirely on their own, completely without human intermediation.
But what if you want to bypass those traditional corporate servers altogether? Well, the Internet Computer, or ICP, approaches execution a bit differently. Traditional cloud providers, your AWS or Google Cloud, they completely rely on centralized servers. ICP, however, is designed as a world computer architecture. Its goal is to host the whole shebang, from the back-end logic to the front-end web assets, all the way to the AI execution itself, entirely on-chain. It completely removes the reliance on corporate cloud infrastructure.
Because of this unique architecture, ICP is enabling what they call a self-writing internet. They're building platforms like Caffeine, which lets non-technical users build full applications just by having a conversation with an AI. Just think about what that means for a second. Literally anyone can become a developer without knowing a single line of code. They also have Ignition, which uses AI agents as autonomous smart contracts that can directly execute tasks and manage resources completely on their own. It is seriously pushing the boundaries of how software is deployed and maintained.
Let's keep building. Layer 3, storage and data, which serves as AI's on-chain memory.
Look, massive AI models with billions of parameters can't just float around in the ether. They require petabytes of storage. That is exactly where Filecoin steps in.
providing verifiable storage for these massive training datasets. And here's the crucial point. It does so at cost 30 to 50% lower than centralized giants like AWS or Google Cloud. When you're training an AI and you need tens of terabytes to several petabytes of data, cutting your costs in half is an absolute game changer for developers.
So while computing networks like Bittensor act as the CPU, Filecoin is acting as the essential hard drive and notary. It ensures that the data is trustworthy, permanent, and tamper-proof using cryptographic proofs. This is absolutely critical for AI compliance in fields like medicine or autonomous driving, because it prevents censorship and single-point deletion. The AI compute layer 100% relies on a robust storage layer like this to validate its models.
But to actually access that memory efficiently, we need an index. Enter the graph. The graph is a decentralized protocol that indexes blockchain data so downstream applications can easily search and use it. And what's really fascinating here is that the graph actively uses AI to optimize its own network. It uses trainable AI agents, specifically something called Gaussian bandits, which is basically a really smart trial and error bot, to automatically optimize the pricing logic for data queries based on supply and demand. So it's literally AI managing the infrastructure that serves data back to the decentralized web.
All right, Layer 4, the reality check. It's time to separate the hype from the reality.
As promising as all of this sounds, we need to be grounded here. The AI crypto sector is highly volatile and faces fierce competition. A recent paper from researchers at Cornell, Princeton, and Yale took a really hard look at the space, and they flagged a few major misconceptions we need to talk about. First, people tend to think blockchain detects AI content. The reality, it only verifies metadata. It cannot mathematically prove an AI made an image. Second, decentralization does not magically fix algorithmic bias. Decentralized governance definitely adds transparency, but the bias baked into an algorithm itself, that remains. And third, just giving an AI agent a crypto wallet doesn't instantly make it autonomous. Autonomy does not equal true autonomy.
The researchers highlighted another hard truth as well. Yes, putting data on a blockchain absolutely prevents post-hoc tampering. But if bad data goes in, bad data is permanently stored. The network simply cannot guarantee the reliability of the original data source. Furthermore, claiming that blockchain is going to cut all AI costs ignores massive technical hurdles around scale and on-chain throughput that the industry is still desperately trying to figure out.
Which brings us to our final takeaway. The AI crypto sector is evolving at lightning speed, offering this modular, multi-layered stack from Bittensor's compute to ASI's agents to Filecoin's storage. It represents a massive, innovative potential to democratize artificial intelligence. But it carries significant uncertainty. If you're a beginner looking into this, ignore the hype. Read the actual white papers, track the real developer activity, and evaluate the real-world utility of these tokens before diving in. The infrastructure is being built right now, but a massive question remains. Can this decentralized, layered approach truly outpace the sheer efficiency and deep pockets of centralized tech giants? Thanks so much for joining us on this explainer, and we will see you in the next one.